All right, let's get right into it. We've all been seeing these incredible videos from AI, like Sora, right? It can generate entire scenes that look almost indistinguishable from reality. It is absolutely mind-blowing. But it also brings up a much deeper question that researchers are scrambling to answer.
So, an AI can create a stunningly beautiful world, but does it actually get that world? Does it understand the basic rules of physics that it's supposed to be showing us? Or is it just an incredibly good parrot, just a fantastic pattern matcher? And that gap, right there, that is the next great frontier in AI research.
You know, this really gets to the core difference between just seeing a pattern and actually understanding something. Today's AI, it's a master of correlation. It has chewed through just an unbelievable amount of data, and it knows statistically that certain words or certain pixels tend to show up after others. A world model, though, is after something way more profound: causal understanding. It's about getting the why behind it all.
And that brings us to the first huge problem. We'll call it AI's missing common sense. It's this fundamental gap in what you might call intuition, and it's the central problem that researchers are now trying to crack.
Think about it this way. A modern AI can show you a perfect, slow-motion video of a glass shattering on the floor. But it doesn't really know that dropping the glass is what caused it to shatter. Nope, it just knows that in its training data, the image of a falling glass is often followed by the image of a shattered glass. It's missing that basic intuitive grasp of cause and effect that, a toddler figures out pretty quickly.
So what's the solution? Well, the big idea that everyone's excited about is a concept called a world model. And honestly, the best way to think about it is like building an imagination engine for a machine.
So officially, it's an internal, simplified map of the world. It's not a perfect high-definition copy, but more of a streamlined version that just captures the essential rules. And what this does is it lets the AI run simulations, playing out all these little what-if scenarios inside its own head, kind of a mental sandbox, before it ever has to do anything in the real world.
Think about playing a game, any game, like Go or chess. Before you make a move, you're constantly running these quick simulations in your head, right? If I go here, they'll probably go there. You're imagining future possibilities to find the best move. A world model gives an AI that exact same superpower, a way to simulate the game, to reason about the future, and to really strategize its next action.
So how do you actually build one of these imagination engines? Well, it turns out there isn't just one single way to do it. Researchers are basically exploring two very different, almost philosophical paths to try and give AI a real understanding of our world.
The big debate really boils down to this. What's more important? Is it better to build a deep, abstract understanding of the world's fundamental rules right now? Or should you just focus all your energy on generating a hyper-realistic prediction of what the world will look like 1 second from now?
So we've got these two main approaches. The first one, we can call it the abstract map. The goal here is to create a really compact, efficient model of how the world works, the physics, the logic, the whole system. The second approach? That's the virtual movie, and it's all about generating a believable video stream of what's going to happen next.
And here's a look at that abstract map approach in action. Now, I know these charts look super technical, but they show something really cool. A model called PLSM takes in all this messy, complicated data about the world. That's the stuff on the left, and it boils it all down into a much simpler, more predictable map of the underlying rules, which you can see on the right. The point isn't to create a perfect picture. It's to understand the fundamental logic, that grid of cause and effect. And the virtual movie path? Well, you've definitely seen that one before. That's Sora. Its entire job is to take a situation and just generate a photorealistic video of what might happen next. It's fantastic at simulating how the world could evolve, putting all its chips on visual accuracy instead of creating some abstract map of the rules.
Okay, so this is all really fascinating as a concept, but does it actually work in the real world? And the answer is a pretty clear yes, and the implications of that are absolutely huge.
So this number, 5.6%, it comes from that paper on the abstract map model, PLSM. When they gave their world model to AIs that were playing old Atari games, they saw their performance jump by an average of 5.6%. Now, I know that might not sound like a massive number, but in the world of AI benchmarks, that is a really significant leap. It's solid proof that having even a basic internal model of the world makes these agents quantifiably smarter.
And this is about so much more than just video games.
I mean, giving AI a world model is a game changer. It means they can learn way more efficiently with less data. It means robots that can actually plan and anticipate things, self-driving cars that can predict crazy, unpredictable traffic situations. We're even talking about scientific simulations that could help us model everything from climate change to complex social behavior.
But of course, let's not get ahead of ourselves. We are not there yet. Building a perfect world model is, you could argue, one of the biggest challenges in all of computer science, and there are some major hurdles still to overcome.
For all the progress, even models like Sora still really struggle with complex physics. Things like how water splashes or how solid objects bounce off each other. The amount of computer power you need to train these things is just astronomical. And like with any powerful AI, we have to start asking the tough questions about risk. We're talking data privacy and also the potential for misuse. I mean, imagine someone using a world model to simulate and plan really harmful scenarios. Which brings us to this final, really fascinating question. If we solve all of those problems, if we can actually build an AI with an internal model that perfectly simulates our world and predicts what's going to happen, what have we actually created? Has it just mastered physics? Or has it, in some really meaningful way, actually learned to think? That's the incredible frontier we're all heading towards.